the Scottish capital of Edinburgh. Destination for the Union Canal. And the nation's historic engineering powerhouse, Glasgow, home to the Forth and Clyde Canal. However, because this pair of prominent waterways never actually meet, moving between Edinburgh and Glasgow by boat is apparently impossible. Engineer Peter Robinson is experiencing the problem for himself.
So we're here travelling along the Forth and Clyde Canal, and if we want to go into Edinburgh and get onto the Union Canal, we've got to go up 34 metres and we've got to get across 500 metres. And without something that's really, really clever, that's nearly impossible. Water actually only wants to flow in one direction, so we've got to manage that. We've got to create something that's going to hold it, allow it to flow and allow us to move the boats backwards and forwards.
It's a challenge similar to one man has long been attempting to overcome. In ancient Greece, an inclined plane was used to take boats up and over land, avoiding the long and dangerous route around the coast. In Germany, a tugboat lift was built to help achieve height change, although the weight it could carry was limited by the strength of its operators. And in England, the first hydraulic boat lift was introduced to help move barges loaded with heavy goods over height. Incredibly, today's engineers have found a solution unlike anything that has been seen before. The Falkirk wheel. The first and only rotating boat lift ever constructed.
It's absolutely unique. It's the only one of its kind in the world.
Capable of moving 600 tons of boats and water over a 25-metre height difference in just minutes.
I think the Falkirk wheel is amazing because it is unparalleled anywhere else in the world. It is the only rotating boat lift. Nobody has been able to develop the technology to be able to do this, to bring this to life and to make this happen.
This one-of-a-kind mechanical masterpiece holds the key to connecting Edinburgh with Glasgow.
The engineering involved to keep it in operation, absolutely no doubt it is challenging, but to do it to such an iconic structure is just fantastic.
At 35 metres tall, the Falkirk wheel stands the height of 8 double-decker buses. This unique landmark is constructed from 1,200 tons of steel. That's the weight equivalent of over 16 space shuttles. The wheel's pair of giant gondolas can carry 600,000 litres of water, enough to fill more than 78 dump trucks.
Come in, BMK.
Go ahead.
Could you initiate rotating the wheel, please?
It's lead engineer Stephen Berry's job to keep this mighty machine turning.
So the gondola there will be heading towards it.
Part of the checks is doing an operation of the wheel before we open it to the public. We'll take measurements at the start of the day, and very soon we'll see this 1,800-ton structure just gracefully move away from the dry well.
Rotation about to commence.
It's just amazing to think that this 1,800 tons is just passing by you without too much effort. I still look at it and wonder sometimes. It's really quite impressive.
In order for this remarkable piece of machinery to achieve the seemingly impossible, its engineers have had to solve a series of problems. How do you move 600 tons of water and boats over a height of 25 metres in a single movement?
The key challenge of what we're facing is trying to take 2 to 3 boats weighing, circa 100 tons and lift them up in one go. And that is just not something that can be done simply.
How do you keep the giant gondolas level as they rotate?
We're moving 600,000 litres of water within the gondolas, so the challenge is to keep the gondolas level at all times.
And how can you carry boats across a gap hundreds of metres wide?
Now we've got that challenge of stretching the final 400 metres to connect to the Union Canal. We need to think long and hard how we can make this work.
In the lowlands of Scotland, engineers have introduced a one-of-a-kind mechanical masterpiece to connect the waterways between Edinburgh and Glasgow. This is the Falkirk Wheel. This unique rotating boat lift can move hundreds of tons of boats and water over a 25-metre height difference. The Falkirk Wheel is equipped with a pair of giant gondolas, capable of carrying multiple boats and hundreds of passengers. Each one holds 300,000 litres of water, enough to fill 7,500 bathtubs. And they weigh in at 300 tonnes apiece, the equivalent of more than 28 Chinook helicopters. And setting this 1,800-ton structure in motion requires an impressive power source. To see the secret behind how it's done, lead engineer Stephen Berry is heading to a location that few can access.
Here we are in the main rotation drive area. We have 2 banks of 5 motors and gearboxes that all work in unison. These are the power units that rotate the structure. So we've got an 1,800-ton structure, and these motors and gearboxes can turn that whole structure very, very efficiently.
To rotate the Falkirk wheel, each of the 10 motors powers a cog that meshes to a rack at the end of the wheel's axle. As the motors turn the cogs engage the rack, and the wheel rotates.
Down here you can see the cog that the motors run and connect with. When the motors and gearboxes operate, that reaction turns the whole 1,800-ton structure.
Once the motors kick into action, being within the wheel while it turns is an environment few get to experience.
The wheel has started to rotate. We're inside this cylindrical tube that takes the whole weight of the structure. This is 23.5 metres long, 4.8 metres in diameter. So yes, it's quite an impressive piece of steel and engineering. It's very unusual to have anyone inside the main axial tube while it's operating. So it's a pretty rare occurrence. Can be quite disorientating at times. To keep ourselves upright, we need to shuffle around constantly to make sure that we don't fall over. The equipment we've just seen is what's carrying out this rotation. As far as engineering concept goes, it's an absolutely amazing structure.
To meet the demands of the traffic travelling on Scotland's waterways, Head of Engineering Peter Robinson is responsible for ensuring that the Falkirk wheel can lift boats faster than any method that has come before.
The fundamental challenge that we're facing here is that we're trying to move multiple boats at a huge amount of water that are going to weigh, hundreds of tons, and we're trying to lift them up to the higher level in about 5 minutes. The historic solution was to go up using the lock chambers and take hours to do it. This is where we've got to come back and find a solution to the problem that we're facing, which is just not something that's straightforward and easy to do.
Could the answer lie with the pioneers of the past? In Southern Ireland, civil engineer Magda Hajdukewicz is travelling up the River Shannon to see a supersized piece of engineering.
We're approaching this big, huge concrete building. It's quite impressive.
The Ardna Crusher hydroelectric power station was once the largest in the world.
This is just unbelievable. Over 90 years ago, it could provide electricity for the whole country.
But building a huge dam across one of Ireland's busiest waterways brings with it a big problem.
So we're on the boat here and we need to get to the other side of the power station, and there is a 30-meter height difference. So we need a solution. How are we going to get from here to the other side?
In 1925, engineer Frank Rishworth was the man charged with finding an answer. What he came up with was a piece of engineering on an unprecedented scale. The Ardna Crusher lock.
Look at this amazing structure. It feels like being in a mine shaft or something. It doesn't feel like a lock. It's just so huge.
It's one of the deepest locks ever built, capable of lifting boats over the 30-meter height difference in just over an hour.
The walls are just so high and I feel like I'm really, really tiny here, and the structure is just overwhelming.
To lift boats, its giant chamber must be filled with a staggering 2.5 tons of water every second.
Can you hear the sirens? It starts filling up now. It's filling up pretty fast. And it's really exciting to hear the sound of the water bubbling.
However, keeping control of such colossal volumes of water posed Rishworth with a massive problem.
There is a high level of water behind that gate. So if that gate was opened quickly now, the water would just rush out very violently.
In a traditionally sized lock, once the gates are closed, water enters slowly through a sluice, and the boat gently rises. But the huge volume of water involved at Ardna Crusher makes this method impossible.
You don't want a rough ride in the lock. You want something that is safe for the boats to pass. So in order to dissipate that kinetic energy, we have to manage the water out in a slow manner.
To do this, engineers at Ardna Crusher turned to a revolutionary design: filling chambers. First, a gate is opened to allow the water from upriver to enter the chamber. As the water falls to the bottom, its energy is dispersed before being transferred on to fill the lock and lift the boat. Almost 100 years since its introduction, the Ardna Crusher lock is still a mind-blowing piece of technology.
It's pretty amazing to be able to just jump in one hit.
Rishworth's innovative engineering allows boats to climb 30 meters in around an hour, an achievement previously thought impossible.
So we're leaving the lock And it was really, really cool to see the water rising and how we were at the very bottom of the shaft and now we're up here in the canal. It's such an amazing piece of engineering.
At the Falkirk wheel, the 25-metre height change happens in a matter of minutes. To move boats at these previously unheard of speeds, keeping control of water is all important.
We're in the dry well area just now. We're below the water level of the main basin, and this folding gate is holding back all the water that's contained within the Falkirk wheel basin. That's approximately 13,000 cubic metres of water. The challenge here is how we manage the water and how we connect that water from the basin to the gondolas. So that's done by this mechanism in front of us here, which extends and mates with the gondolas and allows water and boats to move.
It's a brilliant solution that enables boats and water to quickly transition between basin and gondola and allows the wheel to turn.
When the wheel comes into its docking position, we need to secure it in a very accurate position. So we fix it and clamp it in position with these mechanical latches. And hydraulic rams.
Next, to bridge the gap between basin and gondola, a mechanical seal extends. And the space is filled with water.
We have various valves and hydraulic valves to push water into the interspace.
Once the interspace is filled, the gates are lowered, allowing boats to board the wheel.
And you maybe can hear that there's boats passing above us just now as they enter the gondola.
We're coming in at the lower basin, coming into one of the gondolas, which effectively, a simple way of thinking about it is it's just a large bucket of water. The wheel is going to take us through a single rotation and transport us from the lower level up to the higher level in about 5 minutes.
As you can hear there, that's the operations team saying that the boats are now in the gondolas and the gondolas can now start to be prepared for rotation.
So that's us moving, almost imperceptible. It's big, it's exciting, it's powerful yet quiet.
Amazingly, the wheel has been designed to utilise the weight of the water within its gondolas to help power its rotation.
Now, a perfect way of referring to it is being counterbalanced.
As the gondola at the top descends, its mass is used to help lift the gondola at the bottom.
So in here, the gondola weighs 300 tonnes. We've got the gondola at the other side of the axle here, which also weighs 300 tonnes. So no matter what position it is, it's always going to be balanced. The other gondola that's above us at the moment, and we'll see it's going to come past us, then it is going to carry and transport us up to allow us to connect into the canal at the top of the wheel. The view is just magnificent. So what we've now done in just completing that rotation is we've effectively taken 300 tonnes down, balanced with 300 tonnes up, and we've effectively moved both of those weights around and over each other. The whole revolution of 180 degrees for us has taken 3 or 4 minutes. Yeah, that was cool, wasn't it?
Because of this brilliant system, the Falkirk wheel can effortlessly carry hundreds of tons of water and boats, lifting them over a 25-metre height difference in a matter of minutes. To help connect Scotland's two biggest cities by water, engineers have designed a one-of-a-kind solution. This is the Falkirk wheel. The only rotating boat lift on the planet. The Falkirk wheel weighs an incredible 1,800 tons. More than 3 times as heavy as the world's largest passenger jet. It can lift loads equivalent to the weight of 100 African elephants, over a height difference of 25 meters in under 5 minutes. To carry such oversized loads, engineers need an equally oversized solution. Stephen Berry is lead engineer for the Falkirk wheel.
We're actually below the gondolas just now, and here you can see the bogie wheels that the gondolas ride on. These wheels take the full weight of each gondola, which is 300 tons. So we have 8 bogie wheels for each gondola. Here we are actually on top of the rail system. So this is the rails that holds each of the gondolas.
Cleverly, engineers have designed this system to ensure it requires minimal maintenance.
So we've got a graphite block that's constantly in contact with the bogie wheels to give it lubrication. That lubrication then transfers onto the rails, and that helps us to get a smoother operation that reduces friction on the rails and on the wheels. These rails and these bogie wheels, 24 hours a day are carrying this 300-ton weight, so it's really quite a critical component for the Falkirk wheel operation. Without these, we would not be able to rotate the wheel.
It's only from this privileged position that the true scale of the Falkirk wheel becomes apparent.
You can hear that that's some of the rails starting to move as they come under pressure. When you're this close and you see it just move, although very slowly past you, you do get an appreciation of the mass and size of this rotating structure. It's really quite impressive. You can see the bogie wheels. They're very smooth. They're keeping the gondolas stable.
The bogie wheels and rails that support the gondolas ensure every rotation of the Falkirk wheel is fluid.
It's really quite impressive, even although I've seen it many, many times before, it still never ceases to amaze us that this massive structure rotates so efficiently and so reliably.
So how does this massive structure rotate 180 degrees while also keeping the water-filled gondolas completely level?
We can have up to 4 boats on the wheel at any one time, so we could have more than 200 people rotating on the gondolas. So it's absolutely safety critical that the gondolas do not tilt at all. The challenge is to come up with a mechanism that allows the structure to rotate but keeps the gondolas level at all times.
Could the answer lie with the pioneers of the past? In St. Louis, Missouri, on the banks of the Mississippi, engineer Dan Dickrell has travelled to see a landmark piece of engineering history.
This is the Gateway Arch. An incredible piece of engineering and architecture.
Standing a staggering 192 metres high, and built from 39,000 tons of stainless steel. It's the tallest arch in the world, and it could hold the key to keeping the Falkirk Wheel's gondolas level. Construction began in 1963. And after 2 years of impressive work, the final piece was craned into position in 1965. But the striking curved shape of this epic monument posed a serious challenge for engineers. How do you transport visitors to the top?
The first proposed solution was elevators. The problem with elevators would be it would only take you about 300 feet. The rest, they'd have to walk stairs or ramps. This wasn't a viable solution. The second proposed solution was escalators. The problem was escalators can only go so high, so you have to have a series of escalators that would move the passengers slowly up to the viewing gallery. This wasn't used because it would be too labor intensive to maintain.
With elevators and escalators limited to travelling in straight lines, a new and unique solution was required to conquer the arch's curve. Tasked with solving the problem was Dick Bowser, a college dropout with no formal engineering training. Incredibly, he had the answer to the people-moving problem.
And this is what he came up with. It's a unique piece of engineering.
Bowser's innovative tram can carry passengers through the arch in one seamless movement. And the concept could prove useful for the engineers at the Falkirk Wheel.
So here's how the system works. There's a track that goes all the way up the arch. The capsule in this position is suspended below the track. But what happens as it rises, the capsule rotates around. So at the top of the arch, the capsule's sitting on top of the track.
Each capsule sits on wheels within a carrier frame. A gearbox and set of gears powers a chain drive that rotates the capsule around the central axis, turning it counter to the direction of the track, and maintaining passengers in an upright position for the entire ride.
All right, here we go.
To experience Bowser's engineering in action,
Pretty tight space in here.
Dan's taking a trip to the top.
If we look out the window, we can see the angle of the track is changing as we make our way up the arch. And when we get to the top of the arch, this capsule will actually be sitting on top of the track, whereas when we began, it was above us. You can feel a self-leveling process as the capsule slowly makes its way up the track. Oh, my ears are popping. What a cool ride. Ooh, I think we've arrived.
Since its opening, the tram has travelled roughly 200,000 miles, carrying over 18 million passengers to the top of the 192-metre monument.
Oh, wow. What a view. Oh, that's so cool. So we're 632 feet above the ground. We're really high up, so it makes for a spectacular view.
It's an experience that would be impossible without Bowser's one-of-a-kind people mover. And the capsule's innovative self-leveling technology has gone on to influence transport systems around the globe. At the Falkirk Wheel, each gondola uses a self-leveling mechanism similar to that at the Gateway Arch.
Here you can see some parts of the stabilising mechanism. That's these large cogs that you see. Now, this particular cog is fastened to the wheel building, so this cog does not move. We have a cog on this end of each gondola. We then have this gear. This is the connection point between the fixed cog on the wheel building and the cog on each of the gondolas. So this mechanism ensures that the gondolas are always level. When they are rotating, they are always level.
As the Falkirk wheel turns, a cog attached to each gondola rotates in the opposite direction. This movement drives a gear, which orbits around the fixed cog on the wheel building, keeping the gondolas level and stable.
As we can see, the wheel is now rotating. This fixed cog remains in its fixed position. This gear is being driven by the cog on the gondola as the wheel rotates. As the gondolas rise and this gondola goes down, both the gondolas are perfectly level. So that's all achieved by this stabilising mechanism. So we can see the other gondola coming up to the top now, and you can see its gear, which is in constant connection with the gondola cog and the fixed cog. The scale of things at the Falkirk wheel are pretty big. And this is just another example. This is quite a simple but ingenious solution to keeping these massive 300-ton gondolas perfectly level. So we must take our hats off to the designers. They've really thought this through, and it works really well.
In Scotland, engineers have unveiled a pioneering mechanical giant. The Falkirk wheel is the world's first and only rotating boat lift. Built to help connect Edinburgh and Glasgow by canal. It's a feat of engineering unlike anything that's ever been seen before. The wheel can move 600 tons of boats and water, the equivalent weight of more than 350 family cars. It's fixed together by 15,000 bolts and has been designed to turn 10 times a day for 120 years. To connect the waterways between Edinburgh and Glasgow, engineers must overcome one final obstacle. Richard Miller is Director of Infrastructure for Scottish Canals.
There's some real challenges on this site. How do we get from that structure that's the Falkirk wheel, how do we stretch across the hillside and make that connection that can hold the canal, can keep the water in place and can allow those boats to sail from one side of this site to the other? So as engineers, we needed to think very hard how we could make as efficient a solution here as possible.
To find the answer, the Falkirk Wheels team must turn to history's great innovators. In North Wales,
it's absolutely beautiful out here.
structural engineer Luke Bisbee is on the River Dee.
I think up around this corner is where it starts to get really interesting.
During the canal building boom of the 1800s, this rolling landscape posed the engineers of the day a serious problem.
A valley like this doesn't lend itself to canals. Canals need flat land with a small gradient.
With the route through North Wales essential for industry, a solution was needed that could allow boats to cross the valley.
Building a masonry structure just simply wasn't an option. It would be too expensive, it would take too long, and would present too large a technical challenge.
In 1795, engineer Thomas Telford came up with an answer. The Pontcysyllte Aqueduct. An 18-pier giant, unlike anything the world had seen before.
Look at that. Absolutely jaw-dropping. Quite a rare view. 38 meters above my head and stretching 300 meters from that side of the valley to that side. Definitely one of Telford's most amazing achievements.
This game-changing structure totally reinvented the ancient ideas behind building an aqueduct.
Don't get a chance to canoe under a Telford very often. Yeah, beautiful. What a beauty.
And this incredible crossing is about more than just looks. It's also an engineering pioneer.
Now, whilst it would have been possible to build a structure like this using standard methods with masonry, they would have ended up with a structure that was so massive and so costly and so time-consuming to build that it would have been impractical and could never have gone ahead.
To span the massive 300-metre divide, some 38 metres above the ground, Telford turned to a brand new material, cast iron.
Using cast iron allowed Telford to decrease the size of the bridge, the overall scale, to decrease the weight of the arches, and to end up with towers that could be more slender, could be hollow inside, could keep construction costs down, and could keep the time of construction down.
Far stronger and lighter than stone. Working with cast iron allowed Telford to build a structure capable of carrying boats across the valley.
And we can see the result, which is actually quite an elegant, quite a light structure when you get down here and you look at it. Really innovative use of this new material. Otherwise, this bridge would have been impossible to build.
On its completion in 1805, the Pontcysyllte Aqueduct was the highest navigable waterway in the world. A title that, remarkably, it retains to this day.
Absolutely breathtaking views here. What a masterpiece of engineering. So how bizarre it is to be up here on a bridge, high up on the River Dee, and to have a boat here coming towards us across the bridge. This is something you can't see at this height anywhere else in the world. And to imagine that it was built 200 years ago is pretty staggering.
And this boundary-pushing crossing continues to influence and inspire engineering projects around the globe. The Falkirk Wheels engineers have taken Telford's historic innovation and refined it for the 21st century.
So now we are on the aqueduct. The Falkirk wheel just beyond here, the aqueduct stretching out ahead of us. An amazing piece of engineering made out of reinforced concrete with 30 metres above the ground. So over this distance here of 100 metres, we go from the solid ground all the way stretching out across the sky and then joining with the Falkirk wheel. From below, it hangs in the air, supported by these piers, and then these amazing hoops at the top of it that shape it so that it creates this architectural feature, shaping the landscape into the distance.
And just like the Pontcysyllte Aqueduct, this stunning structure is only possible thanks to its ingenious engineering.
We put piles down into the ground to make sure that it had a solid foundation, and then creating a structure that would allow us to pour the concrete, reinforcing that with steel so that it would be strong enough to carry hundreds of tons of water. There is no doubt that we have looked at the best of history. We have looked to the past and we have taken those ideas, we've developed them, we've used modern materials, and we've created something here that is an amazing piece of engineering.
Working in combination with the wheel, the aqueduct allows engineers to achieve their ambition, and join the waterways between Edinburgh and Glasgow.
You can see the boat passing out of the gondola. And this shows just how important the aqueduct is. It is the connection between the Falkirk wheel that has lifted the boats, and then it will connect to the land, and the canal continues off towards Edinburgh.
Thanks to these three mighty pieces of engineering, boats can now complete a journey that would have once been impossible. For the team behind this one-of-a-kind project, the scale of the achievement is undeniable.
We get people coming from all over the world to come and have a look at it. It's inspirational. You just have to see it in motion to find that it is just something that is iconic and just outstanding as a piece of modern day engineering.
I'm privileged and I'm proud to be part of the team that look after this magnificent structure, and we see it on a daily basis that it attracts people from all around the world.
And really proud of how the engineers all work together to develop such an amazing, innovative and 21st century solution.
By counterbalancing its pair of enormous gondolas, powering the movement with 10 hydraulic motors, and keeping the whole operation safe using stabilizing gears, the Falkirk wheel is able to accomplish the seemingly impossible and effortlessly lift boats in a way that has never been done before. It's a feat that all involved are rightly proud of.
The Falkirk wheel definitely is an iconic structure. You know, it's a unique design, it's a unique application. We take great pride in being able to work on this structure.
By learning from the great pioneers of the past, adapting, upscaling, and overcoming huge challenges.
People said it could not be done. To create a new waterway, to create a new boat lift, and to find a way of joining those canals together. There's no doubt it's proved to be a massive achievement.
Engineers have reinvented the wheel.
It's completely reimagined how to create a boat lift, to be able to move boats and massive structures, massive weights, which makes it incredibly special.
They've succeeded in making the impossible possible.